So our next speaker needs no introduction either, Dr. Raymond Cloyd from K-State. Is anybody here who does not know him? Okay, but I will introduce him
No
anyway.
laughing.
Yeah. I mean, you know, he is very well known. He visits my class once every semester. He talks to my students. He does guest lectures for us. So my students know him really, really well. So do I. So anyway, so Dr. Raymond Cloyd is a professor and extension specialist in horticultural entomology and integrated pest management at Kansas State University. And Raymond's research and extension program involves pest management in greenhouses, nurseries, landscapes, turf grass, conservatories, interior-scapes, Christmas trees, and vegetables and fruits. And Raymond is also an extension specialist in horticultural and ornamental entomology for the state of Kansas. Major clientele includes homeowners, master gardeners, and professional and commercial operators. Raymond has a Master's of Science degree in entomology from Purdue University, and he has a PhD Doctor of Philosophy in entomology from Purdue as well. Dr. Cloyd has won several awards. I'm not going to list them all, but he has a whole page of publications and awards. You can always Google and look up his CV online. And the last one I think I saw him receive was the American Society for Horticultural Sciences. He won for the best publication, I think, right?
I don't remember.
Yeah, yes, he wants too many. So, yeah. And today, and of course, he's published several books, and also, he's published several refereed books as well, and pocket guides and related publications. And today, he's going to talk about, let me get the title. Hold on. Oh, there we go. There it is. Today is going to talk about pest management in urban horticultural systems. Welcome, Dr. Cloyd.
Okay, thank you, Leica. Well, good afternoon. I'll try to keep you awake as much as possible. But I appreciate Leica inviting me tomorrow. I'm having a workshop from 9 to 11 on pest diagnosis and management. What I want to cover today is pest management in the urban horticultural systems. There's a handout. I apologize for not giving you all one. We do have some budget cuts we have to deal with, and so I only made a certain number. What I want to go in today is talk about pest management, go back to the fundamentals of pest management. I think we've gotten away from the true fundamentals of pest management, and that is knowing the biology, the behavior, and the life cycle of these insects and mite pests, and targeting the weak link in the chain. We tend to just grab the pesticide bottle and just spray with no thought about what we're doing. Then we're going to get into some, actually, I don't use integrated pest management anymore because we've overused that term. So I tend to use either plant protection or plant health. And then I want to talk about this. This is a recent development that happened last year, the impact of systemic insecticides on pollinators. And what has become a plethora of misinformation. And what I want to talk about is kind of get you a little more educated in what's going on with that scenario. So let's go ahead and get started. The always question is, why are there pest problems in urban horticultural systems or more definitively landscapes and gardens? Well, it's because insects and plants have an association. They had this before we even were on this planet, basically. And so what you have to think about is landscapes and gardens are dynamic. They're ecosystems. And the thing to remember is not all insects and mites are bad. There's a lot of good ones out there, a lot of good ones that regulate populations of bad insects. What happens is when we go into pesticide, we disrupt that system. And I'll show you examples of that as we go. But what's involved in these systems is you have a plant, the host. It's fed upon by a herbivore or pest, caterpillar in this case. Now, the plant doesn't just sit there and get eaten. It produces chemicals, either directly to ward off the herbivore, or it gives off volatiles that lure natural enemies to attack that herbivore. That's indirect. The direct is the plant produces compounds. We call those allelochemicals or secondary metabolites. And that's direct. And some of the most toxic compounds on the planet are derived from plants. The indirect is the plant giving off volatiles that lure natural enemies. Okay? This is really what happens in nature, and that's what makes these entire ecosystems really dynamic. So first we need to, it's really important to understand the life cycle, the behavior and biology of these. And what you're looking for is the weak link in the chain. the weak link in the chain. You know, where can I really target my efforts to really kill a lot of these bugs, enhance mortality factors? Okay? Let's take the mealybug, for example. How many mealybugs out there? Oh, I love it. We rear them. If you ever want some, let me know. We'll send you a whole plethora of them. We rear citrus mealybug. We used to rear lone-tail. But mealybugs and scales, if you understand their life cycle, it'll enhance your ability to regulate, or I'll say suppress population. So let's go over this life cycle. The crawlers, these are the most susceptible life stages. Why? They don't have this protective waxy coating. Okay? So the early end stars are most susceptible to, I will say, sprays, contact insecticide sprays, because they don't have this waxy coating. As soon as they start developing this waxy coating, that protects them from most contact insecticides. The material beads on the surface of their body, and then never makes it down in the cuticle and where it can penetrate the skin and kill them. Okay? Same with scales. Scales are very susceptible to spit, if you want to do that way, it's not organic, water, when they're at the crawler stage. That's when you're going to get 90% mortality, or around that, when you target that early instar stage. Okay? And of course, again, when the mealybugs get to this stage, your level of efficacy is probably going to go down to 40%. You just cannot kill enough of them. And most times, homeowners, what do? They start seeing problems right here. That's when I get the calls, and my recommendation is just throw the plant away. You're not going to be able to save it. Throw it away. Give it to your neighbor if you like, or your former neighbor. You know, so basically, you know, but looking at the weak link in the chain is right there, basically. Now, obviously, I know that when you're dealing with simultaneous generations, you're going to have all these life stages there at the same time, which means you're going to have to make more frequent applications to kill most of those early crawler stages. Okay? Speaking of scales, here is calico scale. Now, what's on the branch here are the crawlers. That's when you want to be out there with a soap, oil, or whatever your desirable contact insecticide is. Hard spray of water will knock them off also. The problem is when they get to this stage, it's too late. You're really not going to get much mortality at that point because the scales are not feeding as much. The females are going to reproduce, lay eggs, and you're not going to have much mortality. So again, timing is when, and we'll talk about ways to enhance your timing by using some phenological indicators and some other means of monitoring for some of these pests. Two-spotted spider mite. Basically, egg, larva, nymph, and then adult. This life cycle can occur at 10 days, 7 to 10 days when it gets over 85 degrees Fahrenheit. So another thing is monitor temperature. Insects are cold-blooded, and the higher the temperature, the faster it takes them, or quicker it is for them to develop. They don't do very well in this temperature because basically it's too cold for them. Why do we have more problems with insects and mites in the late spring, early summer? Because it's hotter. They respond to that. Okay? So what that means is you have to make more frequent applications of an insecticide in this case because they're going through these life cycles and generations at a much quicker pace. So pay attention to the time of year. The time of year is very critical. Another thing is the plant. Key plants are going to get certain pests. We know that. When I mention burning bush, what's the first problem you're probably going to think about? Spider mites, marigolds. Spider mites, thrips, they get everything. Earwigs. So certain plants will get certain pests. And we call those key plants. And then the pests they get on are called key pests. And so you kind of focus in your efforts when you're dealing with those. So giving you the background, the life cycle biology, that's the way to help manage these or regulate suppressed populations and help time application of insecticides or other means we'll talk about. We have to think about the primary plant protection strategies. And these are scouting, cultural, physical, pesticides, and biological regulation. This has not changed for 50 years. This is still the same. I'm going to go over the fundamentals that have not been, I've talked about since the 1980s, when I really started getting into this, the early 80s overall. And being 24 years old, that's pretty, not really. You guys, I know it's getting late, but think about that. So 20 being actually I'm 27, but I'll think about that later. Mentally, I'm 27. I always think of geologic time, not relative time. Don't you all do that? You're only as old as you feel. That's the way I feel too, yeah, basically. So basically the first thing is scouting. You know, I had a business in California for 10 years, Ray Cloyd's landscape maintenance, designing, consulting, and on probably the garden spot of the universe, the Monterey Peninsula. California, which I'm originally from, if you know where that's at, that's the garden spot of the universe. Monterey Peninsula, Pebble Beach, Pacific Grove. I mean, I don't know why my dad moved out of there, but you know, the thing, the business is you have to look to, the first thing is pest identification. You've got to make sure that you're dealing with a pest and if it's going to be a problem. Okay, based on the numbers. You only can do that by scouting. If you're not scouting, you're going down the road with blinders on. You have no clue about the dynamics in these landscape systems. And I used to do this. Okay, and you can educate your consumers, say, I'm doing this so I can save maybe having to spray and causing more problems than if I don't spray. And we'll talk about that. Two-spotted spider mite's a good example. Two-spotted spider mite, of course, is a dry summer pest. Doesn't like it cool and moist. They're on the underside of leaves, all life stages, because they do not like sunlight. But again, they don't fly, so you have to hit them over a white piece. Take a branch, hit it over a white piece of paper, basically, and count the number of mites on there. And they're going to be very slow-moving mites, and you'll see the two spots on their body. So you can really tell really quickly if you need to do something or actually don't need to do anything at all based on the numbers that you're getting, okay? Because there are a lot of natural enemies that will feed on spider mites. Predatory mites, other insects that will use them as a food source. One way to deal for scale crawlers is I used to use double-sided sticky tape. You wrapped it around certain branches, and when the crawlers went over that, you can tell right away, be out there with some type of pest management strategy, whether it's soap, oil, water, whatever. That's when you're going to get your highest level mortality against these insect pests, is some type of sticky tape approach. Okay, worked for me for a long time, and I still recommend it. Okay. The thing again is going back to identify. Does anybody know what these are? Great, yeah, green lacewing eggs. Now I got a call. Green lacewing eggs. Green lacewing. You didn't know that, did? No. Oh man, you got to get out there more often. Yeah, that's what I thought. Yeah. Now, yeah, you've seen them. Yeah, but I get a call from a homeowner wanted to know what she could spray for these because she thought it was a pest. So I had to educate them. No, these are the green lacewing eggs. The reason they're on stalks is because they're very cannibalistic, and if they were all laid here, they'd eat each other, and you'd have one fat, juicy green lacewing as opposed to a couple smaller ones. And I have a younger brother, so I think about that, basically, a little bit. But yeah, these are green lacewing eggs, but most people don't recognize that. So again, pest or identification of what's there is going to help you determine what if you need, because sometimes doing nothing, believe it, is actually the best approach. And we'll talk about that as we go. So again, these are green lacewing eggs. Leave them alone. Leave them alone. That's right. You typically see them with lace bugs, other sucking insects, and they're feeding on these insects. And they're voracious feeders on aphids. They suck them dry, and they throw them off to the side, and they go after another one. Yeah, that's what I thought too. So basically, you know, one thing that I like is, you know, I was a horticulturist before I was a plant pathologist, weed scientist, then became an entomologist, is that, you know, putting in plants that don't get bugs or don't get very many bugs is one way to alleviate problems by designing landscapes. That doesn't mean you have to use cactus all the time or yucca or things like that, even though they will get pests. But just looking at plants that don't get too many pests. And for example, this is in my yard. My wife did not like this, but that was tough. This is thuya with 1 year of damage from guess which bug? Bagworms. I was doing a test, only one replication, and 1 year they wiped it out. And so after I told my wife I'm running a test with one replication, she said, well, what are you going to do? I'm going to cut it down and we're not going to plant any more thuyas. And we took all our thuyas out, and because I don't like to spray. And so we don't plant thuyas, and we don't get bagworms because the other neighbors do, so they get the bagworms, and we don't overall. But people ask me, you know, can bagworms wipe out a plant? You bet they can. I mean, when you get high numbers of bagworms, you don't do anything, they'll kill a plant. And this thuya was SOL. And since they're taping me, I won't say what that means. So basically overall. So now we have something else in there that doesn't get bagworms and other pests. Plant protection, these are the fundamental basics. However, people forget about these. Sanitation is really critical. You know, remove weeds. Now, when I say weeds, I don't mean marijuana. That's a different weed. And so weeds are crop residues. Why? These are places for insects to overwinter or reside on before they get on your range. Many weeds are hosts for different insect and mite pests. Especially those that are prolificous, which means they feed on a wide diversity of plants. Cultural, we'll talk about this. What I want to talk about is improper cultural practices and how that leads to pest problems. And this occurs all the time. And then physical, either pruning, tilling, forceful water sprays, hand picking, and you know, this is always the first defense, and sometimes this is just enough to do the job depending on the time of year. So weeds, you know, here's oxalis, you know, the weed from you know what. This is not, well, I think it's a beautiful landscape, but that's my own perception. But basically, these weeds are doing two things. They're harboring insects and mites, and most importantly, they're reservoirs for the viruses that some of these insects, especially the phloem feeders like aphids, can vector. So not only are weeds serving to compete with the plants there, distracting from the appearance of the landscape, but more importantly, they're sources of insects and mites, and they're reservoirs or inoculum sources for the diseases that some of these insects and mites can vector. Okay? So that is really where, you know, weeds, or what we call a plant at a place, you know, you need to think about those issues. What about culture practices? This is, to me, 95% of insect and mite problems occur because of improper cultural practices. The first one is plant selection and placement. Put a plant in a location which is desired. Never put a white birch on the south side of a building painted white. That's a stress factor. You know, if you're going to do that, plant Betula nigra, river birch, which doesn't get bronze birch borer. Okay, so let's go over these and I'll give you some examples. The first one is don't overwater. This is a guy that left his soaker hose on a long time, and now he has a fish blake. You know, overwatering, what's it do? It suffocates the plant. And then what does underwatering do? It dehydrates it. And one of my favorite scenarios is we have some dry weather for about a month. The soil is caking. It rains heavily overnight. And then the homeowner, about a week later, complains their plant's dying. Well, you know what the issue is? The soil was so hard, the rain just washed off. You never got percolation. Remember, when you're watering trees and shrubs, it's deep, infrequent irrigations. Get it down. You want those roots down way in the soil profile so when we do get dry conditions, they can tolerate it. Now, annuals and perennials, you can do different things, but avoid overwatering. Houseplants, homeowners are the worst for houseplants. They water every day, and then they wonder why they get dead plants or fungus gnats all over the place. Okay, so watering is critical. Fertility also. We do know that many insects and mites, when you over-fertilize, you can stimulate aphid outbreaks, scale outbreaks, spider mite outbreaks. We've done this, even mealybugs. Why? You have enriched that plant to be higher in proteins and amino acids, and that's what insects and mites use for development and reproduction. Proteins, amino acids. When you over-fertilize, you're making that plant a richer food source for different types of insects and mites. And that's why you need to do what is take a soil test before you do any fertilization to determine, do I really need to fertilize or not? And that goes to turf grass, which requires a certain higher nitrogen levels than trees and shrubs, which require more potassium and phosphorus. Scales, spider mite, what else? Aphids, scales, spider mite, and even mealybugs. In our studies, we've seen mealybugs respond favorably to plants receiving too much fertilizer or beyond what they should be receiving. Okay? So I can spend an hour on this, but I can't because of time. But the bottom line is twofold. Get a soil test, and then read the bag label to determine how much to apply. When it says 1 pound per thousand, don't apply 3 pounds per thousand because that could stimulate plants to have a higher level of protein and amino acids, and they're going to be a more viable, richer food source for certain insects and mites. Okay, makes sense? But again, This is the cultural practices resulting in insect or mite pest outbreaks. Improper mulching, I still don't understand why we have this volcano mentality. I was a volcanologist in an earlier life, so when I see this, I always think of Krakatoa, Tambora, Mount Vesuvius. You remember those volcanoes? Mount St. Helens? It's really cool. But the problem is this tree is going to die in 2 years because the mulch is suffocating it. And then it's going to stress, and then it's going to get what? Wood-boring insects. Wood-boring insects are opportunistic, and they attack stressed trees. And this tree right here is going to succumb to wood-boring insects, which are not the primary cause of death, but the improper cultural practice. In this case, improper mulch technique. Yeah, Ed?
Then why does everybody do it?
Ed asks, why does everybody do it? I do not know. Yeah, somebody's selling lots of mulch. In my business, yes, ma'am.
If you notice in the city of Oakland Park, we did not do that, and neither did the lake.
Well, I commend you for doing that. My recommendation was a 2 to 3 inch mulch layer, a foot away from the tree. This is what I did for my business, and an inch away from the crown because you don't want, but a 2 to 3 inch layer is all you need. And you want it quite a coarse. This is really kind of fine, which means not only will insects be a problem, but voles will get in there and girdle the tree. Voles are a vertebrate. They look like a little mouse, a rodent, and they'll get in there and they'll girdle the tree looking for moisture. It's a great hiding place from their predators. So I have no idea why people still do this. It befuddles me. So, and then on top of that, you water, and you've got another problem. It's a moist mulch. This was when I was in Oklahoma giving a talk. These trees are SOL. I mean, look at this one right there. I mean, that's not pretty. Well, not really. I guess no, not really pretty. But look at this situation. Watering a very fine mulch on the ground. I mean, this is just this is an invitation for disaster. So again, and of course you can stress. Now I want to point that stress is the #1 reason why plants die, because stressed plants are more susceptible to insects and mite pests. That's an easy equation. Stress equals insect pests, particularly wood-boring insects, because the plant can't defend itself. It's having to make a choice between growing or defending itself. Whatever resources are available, or the limited resources, it allocates them to growth. So the tree just doesn't defend itself, and that increases its susceptibility to these wood-boring insects. Make sense? So there's so if trees could think, they would make a trade-off between growth, storage, and defense, and everything is going to go into growth, because it's a survival mechanism to them. Okay? Now, there are concerns about mulch, and that is, this is a little too much mulch. You know, that's, somebody's selling mulch to somebody, I know that. And I see that, and I think of Mount St. Helens right away, because it does look like Mount St. But there's the poor tree, and again, it's just smothered in mulch. Somebody's making money out of this deal, I know that for sure. What about pruning? People don't understand that pruning, proper pruning, can minimize problems with insects. But this is a coat hanger. This is bad pruning practices. Why? That pruning cut will give out volatiles that will lure wood-boring insects. And then what they'll do is they'll lay eggs on the surface of that. The eggs will hatch into larvae, crawler. They'll bore through the tissue and unrestricted be able to get in the tree. Where do you make your pruning cuts? The branch collar. Why? Because that's where it seals. Every time you prune a branch, the volatiles are given off. And that's where you want to be sure to time your pruning when insect pests are not too active. How do you know that? Well, you can look at in the books, but let me give you one example. White birch should never be pruned between April and August. Why? Because the volatiles given off between April and August will attract bronze birch borer females. And they will lay eggs, and you will have a borer issue. Okay? So proper pruning technique and then timing. Timing is also very critical. Okay? That's why we prune in early spring, because that's when insects are not so much of a problem. If you prune in summer, there are insects, much more problematic issues with insects at the time of year. Okay? So pruning is very critical. It'll lead to, and then of course you don't prune too much because you don't want a lot of new foliage coming out because that's easier for insects to feed upon. So again, timing and technique are critical for minimizing issues with many different insects and even mite pests. Pruning out is a good way to remove insect pests, as long as you don't distract from the appearance of the plant. Fall webworm. Everybody know what fall webworm is? Easy. If you get localized infestations, just prune it out and then give it to your neighbor or whatever, put in the whatever you fancy. But the reason is because they're very hard to deal with anyway, so just pruning it back and putting it in the compost pile, putting it in a seal bag, and then putting it in the sunlight, and they'll die because of heat exhaustion. But pruning is a very quick and easy way to remove many of the caterpillar pests and even the beetle pests that are out there. Okay? So pruning is very effective. Some insects don't like to be picked off. There's one, this is one of my cartoons showing the, but hand picking, yeah. Hand picking is very good against that pest, bagworms. Why? It goes back to the biology and the life cycle. Bagworms overwinter as eggs. The females, before she dies, and remember, female caterpillars stay as a caterpillar, they don't become an adult moth, they can lay between 500 to 1,000 eggs in those bags. Okay? So what you do in the winter and now is you get a bunch of people together and you just have a weekend of picking bagworms off of the trees and stuff. It really gets you out of the house. You get camaraderie. You get to know people, talk and stuff. Gets you out of the house. And what's really interesting is people actually, they get together and have these and they burn them. I mean, look at, isn't that great? You know, companionship. Talk about, who caught the most bagworms. Have a contest. Really, this is really, and the reason is because if you do this, you'll minimize bagworms for the next generation. And people just do not. I mean, in my house, I go out there and I just pick off bags, put them in soapy water. Some people put them in some kerosene to light it, and that's something different. But then you're killing them. I mean, this is again finding that weak link in the eggs and exploiting it. And this is a good way to do, because normally sprays will work, but you could be on top of it. June, July, and August, once every week, because all the eggs don't hatch at once. They hatch over probably a 4-week period. Okay? So again, I think this is a good this is good for weekend parties. This also works, but not to this extreme. This is going to blow your trees out of the ground. But forceful water sprays, I've been making recommendations for 10 years on those, and I'll get an email that says, this worked out really good. About twice a week, I went through my garden landscape, for shrubs basically, and I just blast them off. Now remember, water is not a registered pesticide yet. So you're using it off label, so don't let anybody see you doing this basically overall. What are the benefits? There are many benefits, but one is it quickly removes all the life stages, the eggs, nymphs, larvae, pupa, and adults of insect and mite pests. And one pest in particular is scales. When scales die, they stay on the plant. So a lot of times people think they get scales on their plants, but those are last year's scales. All you have to do is take your finger and put it under them and flip them off, and if it comes off easy, it's last year's. But forceful water sprays removes all the life stages and old scales at the same time. Spider mites hate this. They don't like water. So that means you've got to get it on the underside of leaves. But a very quick and dirty way, and I get the questions, Ray, will they come back? No. Aphids, their mouth parts are broken off, so they starve to death. And many insects, that's a very physical harm to them. The other thing is natural enemies, the ground beetles, they'll eat them when they've hit the floor. So again, this is a very quick and easy way to remove infestations. Cleans the plants, and more importantly, it preserves natural enemies. There are no residues. Now, yes, it will kill them as with the water spray, but there are no residues, so they can come back very quickly. Okay? And again, prevents insect and mite populations from building up, and you avoid these sudden outbreaks. And when these sudden outbreaks occur, that limits you in your options of what you can do. And unfortunately, it boils down to using some type of insecticide. It's really too late. Okay? Row covers are very good for certain insects, especially beetles that transmit diseases on cucumbers, like the cucumber beetle, also the spotted cucumber beetle. Remember, you got to take it off to allow the bees to come in there. But this is a material that allows water to go through and sunlight. And they work very well in vegetable gardens. A lot of times, when I'm visiting the community garden or advising the community garden people, you know, I recommend these, and you'll see these all over the place on their squash or cucumbers, because those are very susceptible to cucumber beetles and those that transmit diseases, okay? Now, another thing to consider is, well, how do insects overwinter? And how can you use that to exploit the weak link in the cycle? Well, insects and mites can overwinter as eggs, larvae, pupa, or adults. They can overwinter on plants, in the soil, on structures. Mimosa webworm and mimosa webworm does this, as does fall webworm, and on plant debris. That's why I promote sanitation, because you're removing many of these overwintering sites. Okay? Let's talk about some of the insects and how they overwinter. Adults, Colorado potato beetle, cucumber beetles, squash bug, one of our favorites, overwinters as an adult, asparagus beetle, flea beetles, and two-spotted spider mite. What about pupa? Tobacco and tomato hornworms, fall webworm, and then one of our favorites, squash vine borer, overwinters as a pupa. What about eggs? Spruce spider mite, I already talked about bagworm, and many of the hard scales, pine needle and oyster shell scale. So knowing the overwintering life stages, how can you use that, how can you exploit that to deal with them, regulate or suppress populations, or minimize populations the next season? Do you have a question, or were you making a bid? Oh, I saw your hand up, okay. You're making a bid, okay. That's all right. I'm cheap, literally, yes, on that. So anyway, I want to talk about this. So one thing is till your garden to bring up the life stages like the pupa and let the birds eat them. Or the sunlight will kill them, because that's why they're in the soil, because they can't take the sunlight. So tilling the garden works. Applying dormant oil. Dormant oils are very effective in killing insects and mites that overwinter on plants. Does anybody use dormant oils? Good, because I think they're underutilized. People don't understand it. Remember, you can only use them in the wintertime, not spring, summer, and fall, because they'll burn your plants. But they're very effective in killing, like spruce spider mite. Spruce spider mite overwinters on plants as eggs, and if you use a dormant oil, you'll kill most of the eggs. Okay? The other one is remove weeds. We talked about that, because spider mites overwinter on weeds and debris. So again, going back to the fundamentals and the basics of plant protection is exploiting some of the weak links that occur in the overwintering stages of insects. Okay? I always promote this. However, okay, let's get to reality. There are certain insects and mites that, man, natural enemies will not control them, and it's hard to get them with some of the other techniques. And that's aphids and two-spotted spider mite. Why? Because of the very high reproductive capacity. One aphid can give birth to 100 live aphids, which are clones, females, and they all give birth. And you can see how spontaneous generation occurs. Spider mites the same way. They do lay eggs, but they can lay lots of eggs. And this is why people ask, well, can't the natural enemies take care of them? No, there's too many bugs for them to deal with. And so you have to come in and help them or intercede. And that's where you have to come in with some type of a pesticide. And there are 4 types. There's contact, stomach poison, translaminar, and this is the big one I'll focus on near the end, systemic. The idea, and I'm not sure this is what everybody wants to do, is get away from the broad spectrum target materials. Makes sense to me. Or malathion and acephate. Broad spectrum, kill everything. Good, bad, the ugly, basically. Carbaryl, 7, one of our most toxic materials to honeybees and bumblebees. Broad spectrum, kills everything. Actually stimulates spider mites. When you use 7, you'll notice spider mites are coming back more frequently. Why? Because it kills all their natural enemies. Kills all their natural enemies. Pyrethroids, which make up most of the market, broad spectrum, kill everything. And then, of course, the last group, which is right now getting the bad press, are these are systemic insecticides. So I think what's happening, and I'm not sure it's consistent, is that we're trying to get away from these strong, broad spectrum, kill everything materials. And that does make sense. There's no doubt about it, from both an ecological standpoint and a reality standpoint. I'm a realist. I haven't been on the academic nipple all my life. I've been owned a business and stuff like that. I know what you people go through. So what we try to go into is contact insecticides, or those, when you spray them, it only kills what you come in contact with. And that includes oils and soaps, are really big contact materials out there. So when you're using these, I think I have the next one, here's dormant oil. Very good against insects and mites that overwinter on the plants. Spruce spider mite is one example, okay? Here's a petroleum-based oil. Kills aphids, mites, scales, whiteflies, even though it has a little bit of fungicidal activity. But again, oils, remember this, are contact only, which means what? What do you have to do? Yeah, direct, but what else do you have to do? And write this down. I think it's coming up. If you're doing it, you have to make thorough coverage of all plant parts, and you have to make repeat applications, especially in the spring, summer. Thorough coverage of all plant parts and multiple applications. They don't have much residual activity once they dry up. Yeah, Rita?
What's the latest you can do a dormant oil spray? Spring's coming over in my neck of the woods.
What's the what now, Rita?
Latest point that you can do a dormant oil spray.
Oh, that's a good. When's the latest you can use a dormant oil? Boy, depending geographically, but my recommendation is late February, first week of March. That would be the latest I would say to use the dormant oil, because that's the least likelihood of damaging the plant.
It's supposed to be over 50 degrees when you apply it, right?
Yeah, the oil, yes, has to be over 50 degrees Fahrenheit. Well, I don't control the weather, but that's sure a good point, yeah. And remember this is, whenever you're going to apply a pesticide, water your plants the night before. You want them turgid and healthy. Never spray a stressed plant. You're going to burn it. You're going to burn it, okay? Always water your plants. But Rita's question, I generally recommend about late February, early March. But again, temperatures have to be above 50 degrees Fahrenheit for them to be active and not become phytotoxic, okay? Good point. Here's an insecticidal soap that you can actually use in organic gardening, which doesn't mean anything. But potassium salt, again, soaps are contact. But somebody asked me, what's the difference? And the oils are suffocants. You smother the insect in the eggs. They work on eggs. Soaps are desiccant. They dry up. They break down the membrane barriers, and they cause the insect to fragment the cuticle, and they go up in smoke. They lose all their water. So they're desiccants where oils are suffocants, okay? But still, contact only, which means coverage is important, and multiple applications will be required. But the benefit of these are there's very little residual activity that can directly harm natural enemies. But if you spray a green lacewing with the soap, you'll kill it. They are broad spectrum, but they don't last. They're not going to inadvertently preserve your green lacewings and kill the aphids. They're going to kill everything. Okay? This is azadirachtin. Azadirachtin is an insect growth regulator, which means it only kills the larval stage of insects. It's a very selective material. It's mostly good against caterpillars, although the label states aphids, beetles, caterpillars, leaf miners, thrips, and whiteflies. In our studies, we haven't been able to kill any of those pests or with this stuff. But we do know, excuse me, caterpillars for sure, because of the insect growth regulator. Very benign, low toxic material overall. As it's derived from the azadirachtin tree, Azadirachtin indica, so it's it's a botanical. Stomach poisons are very good. They're used to kill insects like feeding caterpillars because they have to be eaten to be effective. They have to be eaten or consumed to kill the insect, and they work primarily on caterpillars. Here's one of the products, one of the BT worm killer. And there's the active ingredient, Bacillus thuringiensis kurostaki. Now remember, kurostaki is the one that kills the caterpillars. Israeliensis, the other strain, kills fungus gnats and mosquitoes. Okay, so kurostaki, this is the most selective insecticide we have available. Is this types because it only kills one group of insects, caterpillars, okay? Unfortunately, it'll kill the monarch butterfly caterpillar, a viceroy, and any other beneficials if they eat plants that have been sprayed. But it does only kill caterpillars. I mean, you could actually drink that container, it would never kill you. You get pretty good diarrhea, I can guarantee that. But you are not going to die because these only kill insects. How do I know? You're a very quick audience, I'll say that. It goes back to think that BT only works in alkaline stomachs, and caterpillars have an alkaline stomach. What's the pH of our stomach? It's acid, hydrochloric acid. So there is no way that and I didn't drink that, by the way, Stephanie. No, one of my professors did, and he had to go to the bathroom, and he had a little twitch for an hour, but then he was all right after that. But basically, humans can never die because this is selective only for caterpillars. Okay, and here's the formulation of dipel, which you can use organic production, basically. Same thing, kills caterpillars, just a higher formulation used for agriculture. Spinosad. Spinosad is, I have a warm place in my heart for spinosad because I worked with this material 4 years for it became commercially available. And I was so impressed at how well it worked against two groups of insects, thrips and caterpillars. It is awesome on both of those insects. It also works on leaf miners and also certain beetles, and particularly Colorado potato beetle. It will kill the larva of Colorado potato beetle. But this is a very selective material. It only works on thrips, caterpillars, leaf miners, and certain leaf-eating beetles. It has no activity against mites or phloem-feeding insects like aphids or whiteflies. It has no activity against those. Okay? So another selective product. Not as selective as dipel, but again, very selective. So here we are, TCF. Timing of application, when the weak link in the chain is there, coverage of all plant parts, and frequency of application. Oh, how much time do I have? 2 hours? No. Freaker. No, about 10 minutes. We're getting there, but I got to cover the last part. So this is a TCF. This is I tell every homeowner, I write articles about this. This is how you maximize the performance of every pesticide, even water. Timing when the susceptible life stage, coverage of all plant parts, and multiple applications. That's the way, I boiled it down to 3 words for you to remember there, okay? The other thing you can use is phenology indicators, which people do not use, unfortunately. When something is happening in the plant world, there's something happening in the insect world. That's where we use degree day models. And for example, pine needle scale crawler, or eggs hatch when this species of hawthorn is at 50% bloom. Euonymus scale, which I really like because it makes plants look like snows all the time. Eggs hatch when this same hawthorn is at 95% bloom. So you can use plants when they're blooming to say, hey, it's time to do something. And for example, when Van Hoot spirea is in full bloom, we know that certain insect pests are susceptible, including European pine sawfly, oyster shell scale, pine needle scale, and even lilac borer. When you see Van Hoot spirea blooming, it's time to be out there doing something for a particular pest. Okay? And so where do you get that information? Basically, a great publication is called Coincide. Does anybody have this book? It's called Coincide. It is the best book. I have this under my pillow every night. The information seems to... Nice try. But yeah, and in there it'll tell you when the plants are blooming, what pests will be active at certain life stages, okay? So when I was in Illinois for 7 years, all our newsletter articles, we always put Van Hoot spirea, hydrangea, lilac. When certain trees are blooming, something is happening in the insect world. And you can help that to time your applications of insecticides or miticides. Great, great tool to use. I mean, nature has given us this tool to utilize for plant protection.
Where do you get it?
Pardon?
Where do you get it?
Where do I get it, Rita? On Amazon.com or the Morton Arboretum in Chicago. Morton Arboretum, because that's where Don Orton worked. Donald Orton is, they sell it still. It's about $20.
Our bookstore has it as well.
Oh, great. Yeah, so rush to your bookstore. Yeah, John?
Is it the same accuracy throughout, no matter how long you've had the book, or is it?
Yes. This is the first edition. This is the second edition. there weren't very many changes except the addition of more plant material. Yeah, so it is still a reliable source, even if you have the first, and I have both editions too. But it's, I think Christmas is gone, but next year for Christmas, this would be a good Christmas present. Very inexpensive too. Okay, so I just want to say that this goes back to the fact that many of the insect pests that we deal with are our own undoing. We create these problems. How do we do that? By killing natural enemies. Here's a ladybird beetle larva, green lace. This one eating the, I love to eat the aphid head, decapitating it. Here's green lacewing sucking an aphid dry. Oh, I love this, man. Raises it up, sucks it up, throws it away. Goes to the next one, basically. Scales are attacked by many parasitoids. Here, those are all oyster shell scales, all hit by parasitoids. Aphid mummies on a plant. How many have seen this out there? Most of you got to get out more often. But let me tell you, there's these things. Those are aphids that are dead. They've been by this parasitoid. It's really cool. I wish I'll talk more about that. So what is the impact of pesticides on natural enemies? Well, the main one is we call secondary pest outbreak. And what that means is that you have aphids as your primary pest. You spray with, say, orthene. You kill everything, including the natural enemies of the spider mites. Now, those predatory mites were keeping those populations where you couldn't see them or detect them. But as soon as you sprayed orthene, boom, you've killed all the predatory mites. There now, mites become your main problem, but you still have to spray for aphids. This is an example of ecological disturbance. We call it secondary pest outbreak. And yes, ma'am.
Could you address how to take care of ticks in your yard, and like if there's a timing or something that's not going to destroy everything else?
That's a good question. I'll only say that ticks in your yard, the best thing is keep areas mowed down because they like to get on grass, and when you go by the so I think the best thing is keep the lawn areas mowed as much as possible where you or children or pets are going to be. And then the other one is wear repellent. If you're going to go outside, DEET or Picardian or one of the repellents, I think that's the best way to deal with them. I do not recommend prophylactic spraying an entire area. It's a waste of time, money, and ecologically disturbing. Yeah.
And doesn't it take 48 hours for the actual moisture to get in there to cause Lyme disease?
Well, Lyme disease is caused by the deer tick, which of course is related to deer. That's another biology. Once the deer tick feeds, at 24, 48 hours, it ingests this bacteria-like organism. You don't need to know the scientific name. And then, of course, if you think you have Lyme disease, it's that halo around the red halo around the bite. Go to your doctor right away and get I guess they call it antibiotic or whatever for that, because it is a bacteria, not a virus. Yeah, but it's a spirochete. Burgdorferi. Burgdorferi is the genus. You don't need to know that. Only I do because I study this stuff all the time. But the bottom line of your question is mow areas, repellents. Okay. Does everybody understand secondary? You know what you can also do? Soaps and oils will do this also because they're killing all the natural enemies. And so you get these, this pest now is your primary one, aphids are your secondary, but again, you're back to we call the pesticide treadmill. Okay? I think Lake is standing up, so I better move. I'm gonna kind of move because I want to spend a lot, the conservation biocontrol is basically putting in plants that retain pollen and nectar for beneficials. And here's one of my, this is actually has two things. One of them I didn't want to mean to show, but there are two, okay, you get that, okay? So it's acting as a food source for this parasitoid, but a mating site for these two soldier beetles. So I better move on because they're videotaping this. Let's see, go through. Yeah, okay. Isn't that cool? So the bottom line was I was trying to make a point here is, when you're, once plants are in the landscape, they're susceptible to weather, natural enemies, and all sorts of stuff, and the customers don't know the difference between a thrips or whatever. So I think we can reduce intense spraying by putting them in there, and I used to do this. I mean, customers didn't even know what insects or mites were, and you just let nature do its course. However, when you're dealing with this clientele, how do you get around that? They want everything dead, okay? Bottom line, use materials that are the least disruptive. How much time do I have? Can I get 10 minutes? No? Okay, let me just, honeybees, bumblebees, systemics. How much time do I have? Like I make this, okay, 5 minutes. There's a big issue right now, honeybees and systemics, the pollinators. A systemic insecticide, why was it designed to that? To protect pollinators and non-target organisms. They work very well. And this is how they work. When you apply them as a soil, they move throughout the plant, get phloem-feeding insects. Why the all of a sudden concern? Because of the Oregon incident. A landscape contractor applied safari dinuteferon to 55 European linden trees in bloom. He killed 55,000 bumblebees in a Target parking lot. Now, the thing is, if you read the label, it states, this product is highly toxic to bees exposed to direct treatment. The person didn't read the label. This is a mislabel application that's now transcended into a banning of systemic insecticides, primarily the neonicotinoids. And these are readily available to homeowners. Here they all are: imidacloprid, dinuteferon, acetamiprid, thiamethoxam. These are all neonicotinoids, and there are organizations out there in front of Lowe's and Home Depot wanting them to ban them. It's in the news, people, and they can get in front of your nursery and do the same thing. Here's imidacloprid, one of the Bayer products. Here's acetamiprid, ortho product. I can't go through this, but the bottom line is read, okay, I'm going to get there eventually. Read that publication. This one is a piece of garbage, very unbiased, but this one is really good. Read it tonight or tomorrow. You can download that website for free. That has the best information, non-biased, that's available out there, okay? The question that I have for everybody, I'll put this back up, is I love pollinators, but we got to use common sense. Will banning the neonicotinoids help preserve pollinators? No. What are the homeowners going to do? Spray 7 N contacts, which are much more harmful to the pollinators than the actual systemic insecticides, okay? That's the issue, and we're not using, we're going backwards, people. Unfortunately, humans tend to do that, like an iceberg. So remember, these are ecosystems. They're alive, they're active, they're fundamental. There's a lot of good stuff going on in there. And so, but do you think people are interested in urban horticulture, or are they interested in these things we call the nipple? Well, somebody's giving a talk, and what are they doing? They're trying to figure out, the recipe for the night or whatever, I don't know. But, so basically, this is what we deal with today. It's quick fix. Quick fix. How do you talk about things that have gone over with these people? I don't know what it is. So I'm done. So thank you very much.